Hey guys, magandang araw sa ating lahat. Ah, Today we will discuss about yung logistic regressions. Logistic regressions is actually statistical tools is predicting deals with the predicting the binary outcomes when you are when you have an dependent variables that is binary outcomes, meaning dichotomous outcomes. It is actually logistic regressions. So logistic regressions is just like multiple linear regressions. However, uh, logistic regressions, the dependent variables has two outcomes. Either, let's say for example, the probability of having success and then the probability of having failure in the exam, or the probability of winning the game and the probability of losing the game. So in these examples, as you can see, it's actually the probability. Our dependent variables here is cured, and then our independent variables or our predictors is two, which is intervention and durations. For the level of dependent variables, we have two outcomes. That is what we call binary outcomes. So it is actually the probability of having a patient cured, and which is equal to 1, and the probability of a patient of having not cured. Then for independent variables, also for interventions, we have two levels, which is actually 0, 1. And sometimes kasi 0 is assigned to a patient does not have medical treatment or an interventions. And 1 is having an intervention or medical treatment given to a patients. Of course, we also considered the durations as our independent variables. This actually the duration or the number of days. It measured the number of days with problem before treatment. So bago siyang binigyan ng treatment, they actually measured or they get the number of days na kung saan nagkaroon siya ng nagkaroon ng pasyente ng problema sa kanyang kalusugan, something like that. So in this case study, they want to determine whether this intervention factors and number of days with problem before treatment have an impact to a patient uh, giving to a patient that is cured or not cured. So they want to assess whether this intervention and number of days with problems it can become a predictors of patients to be cured, to patients cured. So, yun ang intent ng case study nito. So, they want to use using yung logistic regressions in Spss. They considered these dependent variables is cured, and then the dependent variables intervention in a number of days as a covariates. And also they want to see whether this intervention and the number of days with problem before treatment has an interaction effect. Okay, because they considered in species we have to consider yung categorical variable. So since we have independent variables, since we have categorical independent variables, kailangan ilagay natin siya dito sa categorical covariates so that our results will definitely uh, accurate and consistent with the interpretations. Of course, since it has two levels, then we considered yung patient, yung i-assign natin na siya as our reference value. And siya yung una na magiging indicators natin. Yung without an intervention as to compare yung with a patient that has an intervention or medical treatment. Continue, because if you want to see the predicted values or you want to see the result of their predicted values together with its residuals, you just click in this menu options. You can also see the Cook's statistics, leverage values, and the residuals statistics. But for this discussion, we will not include this anymore. For the options, I'd like to see yung classification plots. We want to see which among them falls under the patients that is cured, or we want to see when the probability plots occurred that is patient having cured. Of course, we want to see yung the Hosmer-Lemshow goodness of fit to see whether the fitted model is fitting the observed data. Likewise, we want to see the correlations metrics, whether there is collinearity exists in our model, in our final model. And then for the iteration history, we will also see whether there is, we want to see the results of the negative likelihood, and then the confidence interval for our odds ratio, the level of 95%. Okay, click continue. As for our method, we just considered yung enter. Then show is our SPSS result, which is the logistic regressions. As for the case processing summary, as you can see, we do not have a missing values, and our participants is equal to 133 participants included in this study. Then our dependent variable coding 0 as patients who are not cured, and then 1 is patient who are cured. And then for our categorical variables, we included in our categorical in our covariance as for independent variables interventions, then no treatment, 0 assigned to a no treatment, to a person or to a patient with no treatment, and then 1 with to a patient with uh, medical treatment or interventions. Of course, we have 56 for the no treatment patient, and for the 57 for the patient with interventions. So initially in block 0, we considered only the intercept. We included in our model is only the intercept. That's why you can see here is only the constants. So for the third iterations, which is our SPSS convergence, uh, the negative 2 likelihood is equal to 154.084, and our intercept, which is equal to 0.303. Then its classification table that we only included yung intercept, we have actually 57.5% of accuracy in predicting, or this is actually the probability or the percentage of correct matches, meaning 57.5% of accuracy that we really um, give predictions to our observed data. Then for the variables in the equations, since it is only an intercepts, then this would mean that our intercept does not passes. I mean, it passes through 0 because it is not significant. And then our odd ratio for our intercept is 1.354. So for the variables not in the equations, the overall statistics is mm, has a promising model, because as you can see from our overall statistics, the p-value is 0.02, meaning there's an indications that some of our independent variables is significant. Interventions and the interactions between the number of days with problem before treatment and intervention is also significant. So let us see. For the black one method, based on our iteration history, when we included our independent variables, um, we reach only 4 iterations. Species converges into four iterations. So the negative 2 like log likelihood is equal to 144.095. So from this, we get the coefficient of intercept is negative 0.520. And our coefficients for the interventions, we have 1.850. And then for the number of days with problem before treatment, coefficients is 0.034, and the number of days with problem before treatment intervention is 0.087. As you can see from our model, we have a negative value for our intercept. This means, and we have also two positive values for our intercept, for our coefficients. So for the negative value, we have suspicious indications that the number of days with problem before treatment by intervention, or the interactions between the number of days with problem before treatment and interventions effects, has an impact to our dependent variables. So let us be careful to our interpretations, because the interactions effects is significant. For the omnibus test of model coefficients, we have a significant difference between the baseline model and the final models, because our p-value is 0.019. As you can see from our model, even from our step and block models, they are all significant at zero point zero 0.05 levels. So what this means? This means that our final model has is actually adequate, is has an improve as an improvement, mayroon siyang improvement sa ating model, kasi yung deviation from the baseline and the final model is significant. For our model summary, just what I mentioned, our negative 2 log likelihood is 1.4 or 144.095, which is very small or less than the previous one. Our the previous one is 154.084. So this means we have an indications that our final model is very promising, or we have a good final model. For the Cox and Snell R's, 0.085 or 8.5%, which is less than our Nagelkerrick R square, which is actually 11.4%. This means that 11.4% of the variations in y, or in our dependent variables, that has been explained by our final model or by our independent variables. So it's not actually ano, hindi na masama. Maganda na siya. by improving yung final model. And then, as for the Hosmer and Lemeshow test, as you can see, hindi din siya significant at 0.05. This means that uh, the observed and the fitted model is something that they are very close to one another. As you can see from our contingency table, malapit siya. When you divide it into, you know, into eight uh, groups, then the observed and the expected value for our Hosmer and Lemshow test is very close to one another. Likewise, for the classification table for final model, when we included the independent variables, previously we got 54.5%. Now we already reached to 64.6%. So meaning it is increasing our percentage of accuracy to predict the observed data. This is actually the probability of correct matches in the observed data. Of course, for the variations, the variables in the equations, as you can see, for the intervention is not significant. Okay, also the number of days is not also significant. So definitely this data doesn't support our um, study. However, if you try to consider yung p-value nila, if you just consider yung interventions, definitely our model will improve. Let us see after this. As you can see in our correlations matrix, we have actually number of days. So there exists a multilinearity between the number of days with problem before treatment. So we will expect uh, there is a collinearity in our final models. As you can see also the correlations between the intervention and the number of days with problem before treatment is also greater than 50%. So meaning there is also exists collinearity. So basically there is collinearity exists in our final model. Okay, as you can see from our classification plots, most likely yung data natin the version cube is fall under the probability predicted probability of zero point 0.4 and 4, maybe fall under the 50%, 40% to 50%. So meaning 64, as you can see from our classification tables, meaning 64.6% does not give or does not guarantee to give support to our study, because 64.6% is something very close to 50%. So if you try to remove the some of the independent variables in our study, there might our final model will be improving. So, tingnan natin tanggalin yung mga ibang let's say ibang independent variables. Okay. So let us see. Let us see in choosing yung stepwise method. Stepwise method by using forward logistic regressions. So let us see. Okay. So, punta tayo dito ulit. Oops. 57%. Oops. Using forward stepwise method. As you can see, uh, our oh, oops. So there exists yung interventions. So definitely our final model is only one independent variable, which is interventions. Ngayon, kung i-reanalyze mo siya, tanggalin mo yung duration sa ating bar independent o sa ating final model. We'll just include yung intervention. As you can see, oops, sorry, binary logistic function. As you can see, so ang method natin enter lang. Kung tanggalin mo yung duration at saka yung interactions effect, definitely mag-i-improve talaga yung model natin. So, see from our uh, hmm, sorry, ulitin natin. Yung tayo sa binary na categorical and then continue options. Okay, continue. Okay, ulit tayo. So as you can see, sa ating oops, okay, significant na yung ano. So meaning we have now a final model. So intervention is actually has an impact to patient of having patient cured. So that is how the logistic regression uh, plays an important role in predicting the binary outcome. So if you want to uh, you want this video, don't forget to share and like at paki-click na rin yung notification bell. Don't forget to comment if you have some comments. Thank you.